everyone. I am Dr. R.Pushpavalli, MCA PhD, Assistant Professor, Department of Computer Science, Sri Sharda College for Women Autonomous, Salem 16. Today we are going to see the basic concepts of data structures. Data structure are fundamental concepts in computer science essential for organizing and storing data efficiently in computer memory such as DVD, pen drive, hard disk, and memory cards. It enables us to perform operations like access, insertion, deletion of data efficiently whenever we need. Data structures and algorithms. The data structures and algorithms is a study about how data can be stored in different structures. It gives us the possibility to manage large amount of data efficiently in large databases and internet indexing services. Here we can structure our data in different ways depending on what data we have and what we want to do over the data. Data structure are essential ingredients in increasing fast and powerful algorithms. It helps in managing and organizing data, which reduce their complexity and increase efficiency. Whereas the algorithm is the collection of steps or procedures to solve a problem during the managing the data. The insertion, deletion, travel cells, searching and sorting are the common operations we can perform over the data structure for managing and retrieving the data as per our requirement. Classification of data. Data structures classified as primitive and non-primitive. That means primitive data are integer, float, character, booleans. These are the basic data types we call as a primitive data. The primitive data structures are basic data structures provided by the programming languages to represent a single values. That means primitive data are called single value data. These are data automatically stored in a memory disk without any logical operations. Abstract data structure are high level data structures that are built using primitive data types and provide more complex and specialized operations. Some common operations or some common abstract data structures are array, linked list, stack, queues, trees, and graphs. Classification of data structure. We can classify the data structure based on its data type and its physical and logical arrangement in the memory could be classified as primitive and non-primitive. The primitive data structures are character, integer, float, and boolean. The non-primitive data structure again classified into two different groups. The array, linked list, stack, queues are linear data. Here the data were stored in linearly. These data are comes under the group of linear. But the complex data like tree graph sets we can group as non-linear data structures. The physical and logical data structure. The physical data structure refers to the actual organization of the data in memory. Data structures are categorized as physical and logical data structure based on the complexity of the data and its structure. The array and linked list are two common physical data structures which are used to manipulate or create more data structures. It normally stored in the linear format. The array data type is allocated the continuous memory space in physical memory while declaring the variable by the program during the writing of the program. The size of the array cannot be modified. The physical data structures can be linear, but not all the physical data structures are necessary linear. Logical data structure. Logical data structure are abstract models that define the way data is organized, related, and manipulated within a system without getting into the details of physical storage. They are essential for understanding and designing the architecture of the database system. Some efficient data structure algorithms are used in the abstract data structures. The linked list array, queue, tree, graph, and hash tables are the example for the logical data structure. Here, linked list is a physical data structure, but while we using pointers over the linked list, it comes as logical data structure. An abstract data types. It describes the data objects which creates the new data structures and the fundamental operations supported on them. Abstract data types known as a class for object whose behavior is defined by a set of operation and set of values. The combination of user-defined values and user-defined functions we can say as an abstract data structure. Here, it mentioned what operations are to be performed, but not how these operations will be implemented. It doesn't know specify how data will be organized in memory and what algorithms will be used for implementing the operations. The common abstract data structures are array, linked list, stack, queue, tree, and graph. The array abstract data type in data structure is a fundamental concept that stores a collection of elements in continuous block of memory. It allows for efficient access to elements using the indices, and it is widely used to organize and manipulate data. The key property of array is that they store and retrieve the items using integer indices. These items may be anything from primitive data type. The one-dimensional and the multi-dimensional array are different array types in data structure. Classification of data. Data structures classified as primitive and non-primitive. That means primitive data are integer, float, character, booleans. These are the basic data types we call as a primitive data. The primitive data structures are basic data structures provided by the programming languages to represent a single values. That means primitive data are called single value data, ETs. These are data automatically stored in a memory. Stack are used in compilers to convert infix expression to postfix or prefix notation, and subsequently it helps to evaluate the expression. In functional calls regression algorithm, each call is pushed onto the call stack, preserving the state until the function completes its execution, after which it popped off the stack. Stack is employed in memory management system to maintain a history of actions for undo and redo operations. Some other applications are backtracking algorithms, syntax pairing in compiler design, expression parenthesis matchings. Abstract data type in a data structure is a linear data structure model which follows the first in first out principle. That means that the first element added to the queue will be the first one to be removed. Here, adding of elements is done in a one end is called rear, and a removing of the elements done in another end we called as a front. The NQ, DQ, peak is empty or the common functions used in queue. Logical data structure. Logical data structure are abstract models that define the way Data is organized, related, and manipulated within a system without getting into the details of physical storage. They are essential for understanding and designing the architecture of the database system. Some efficient data structure algorithms are used in the abstract data structures. The linked list, array, queue, tree, graph, and hash tables are the example for the logical data structure. Here, linked list is a physical data structure, but while we using pointers over the linked list, it comes as logical data structure. Graph or mathematical structure consisting of nodes and edges. Edges helps to connecting the nodes. Node we can called in another name vertices. They are used to model relationship between the objects and can represent various real world scenarios. Here sample graph is given. Here vertices denoted in the name V. 6 vertices present in this graph and edges. Here 5 edges were present in this graph. Classification of data. Data structures classified as can be represented using different data structures such as adjacency matrix and adjacency list. Adjacency matrix are two-dimensional array with entity ij indicates whether there is an edge between the node I and j. Adjacency list represent each node with a list of its adjacency node. Complete graph is a connected graph, and here every vertex is directly connected to every other vertex, making it maximality in connections. Here each vertex has a n minus 1 degree. Number of edges in a complete graph with a n vertices is n into n minus 1 by 2. The practical applications are limited due to their high connectivity and resource requirements. Many types of graphs named as undirected graph, directed graph, bidirected graph, weighted graph, cyclic graph, and uncyclic graph. Undirected graph, there is no direction in edges, but the directed graph, the edges has with a direction. It means that the relationship between nodes in a one way. But the bidirected graph, the edges has represent both direction. That means A to B relationship and B to A relationship. Weighted graphs are assign a weight or cost to each edge, it representing the directions and distance between the nodes. This could be an actual physical distance, cost, or any other relevant matrices. A cycle graph refers to a graph that contains at least one cycle. A cycle is a path of edges that start and end of the same vertex. An uncycled graph is a graph that doesn't contain any cycle. There is no path in the graph that start and end at the same point. Graphs are used to build various types of networks such as a social media network, transportation network, road or flight, communication network and more other. Network routing management here, pathfinding algorithms like Disaksha algorithm, A-star algorithm, Floyd-Warshall algorithm were used to find the shortest path between nodes in a graph, which navigate the network routing protocols. Depth first search and breadth first search are used to explore the searching operation in a graph. Some other applications are graph coloring and flow network topological sorting. Trees are refers to the hierarchical data structure. Here, each node has a parent-child relationship with the other nodes. Tree, trees are widely used in a data structure algorithm due to their versatility and efficiency in data handling and managing data in hierarchical relationship. Here, root is the topmost node. Other nodes are connected by the edges. The syllabi means the same parent having the nodes means it is called syllabing. Leaf node. The leaf node we can call it as an external node. In this leaf node, it don't have the children node. Internal node. Internal node means these kinds of node which have at least one node as a children. Here, different type of trees were used. Binary tree, a hierarchical data structure where each node has at most two children. Here, binary search tree, AVL tree, and red block tree we can call it as a binary tree. Binary search tree means each node has at most two children, with left child node having the value lesser than or equal to the parent node, and right child node having the value greater than the parent node. Um, this binary search tree efficient for searching, insertion, deletion operation. AVL tree, a self-balancing tree. Such, here, the height difference between the left and the right subtree of the node is at most 1. The red block tree also the self-balancing search tree where each node is colored either red or black and specific rules are enforced to managing the balance. Here, AVL tree ensure the O log n time complexity for searching, insertion and deletion operation. But red block tree O log n time complexity for insertion, deletion and searching operation. Tried, that means prefix tree, a tree data structure used for efficient retrieval of a set of string. Commonly, this tree is used in spelling checker, used in dictionaries and IP routing tables. Heap. Heap is a one type of tree. A specialized tree-based data structure in which the parent node is greater than or equal to max heap or lesser than or equal to min heap. It's called a node. Here, often used to implement priority queue and heap sort algorithm. Commonly, the heap tree is used in scheduling algorithm, memory allocation, and graph algorithm. B tree is a one kind of different tree. It is special tree, a tree data structure optimized for storage systems and database. This kind of tree have more than two children and are kept balanced by distributing the key among the nodes.